This is SpaceTime, Series 28, Episode 65, for broadcast on the 30th of May, 2025. Coming up on SpaceTime, a new theory of gravity which brings the long-sought-after theory of everything closer to reality. Is there a hot side to the moon? And astronomers discover white dwarf pulsars for the first time. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have developed a new theory of gravity which brings the long-sought-after theory of everything just a little bit closer to reality. A quantum theory of gravity would clear the path to answering some of the biggest questions in physics. The study, detailed in the journal Reports on Progress in Physics, claims a unified theory combining gravity with the other fundamental forces of nature, that's electromagnetism and the strong and weak nuclear forces, may well at long last be within reach. Bringing gravity into the fold has been the goal of generations of physicists who have struggled to reconcile the incompatibility of the two cornerstones of modern physics, namely quantum field theory and Albert Einstein's theory of general relativity. The key has been developing a new quantum theory of gravity which describes gravity in ways compatible with the standard model of particle physics, the cornerstone of our understanding of the universe. And in the process, it's opening the door to an improved understanding of how the universe began. While the world of theoretical physics may seem remote from applicable technology, the findings are remarkable. See, modern technology is built on fundamental advances. For example, the GPS in your smartphone works thanks to Albert Einstein's theory of gravity. The study's authors Mikko Partanen and Jukka Tulti, both from Aalto University, say that within a few years, their new hypothesis may well unlock crucial understanding. Now, if it does turn out to lead to a complete quantum field theory of gravity, then eventually it'll give answers to the very difficult problems of understanding singularities at the center of black holes, and even understanding the Big Bang of creation itself. However, we're not there yet. Some fundamental questions of physics still remain under this so-called theory of everything. For example, current theory still can't explain why there's more matter than antimatter in the observable universe. And they still don't know what dark energy and what dark matter really are. The key to this new hypothesis was finding a way to describe gravity in a suitable gauge theory, a kind of theory in which particles interact with each other through a field. Now, the most familiar gauge field is the electromagnetic field. Tulki says that when electrically charged particles interact with each other, they interact through the electromagnetic field, which is the pertinent gauge field. So when particles have energy, the interactions they have just because they have energy would happen through the gravitational field. But a challenge long-facing physicists is finding a gauge theory for gravity, one that's compatible with the gauge theories of the other three fundamental forces, the electromagnetic force, the weak nuclear force, and the strong nuclear force. The standard model of particle physics is itself a gauge theory, which describes those three forces and has certain symmetries. Tannen says the main idea is to have a gravity gauge theory with a symmetry that's similar to the standard model symmetries, instead of basing the theory on the very different kind of space-time symmetry involved in Einstein's general relativity. Without such a hypothesis, physicists couldn't reconcile our two most powerful theories, quantum field theory and general relativity. Quantum field theory describes the world of the very small, tiny particles interacting in probabilistic ways. On the other hand, general relativity describes the grand physics of the cosmic world, the universe as a whole. So they're both descriptions of our universe, but from very different perspectives. And both theories have been confirmed with extraordinary precision, yet they're still incompatible with each other. And because gravitational interactions are weak, more precision's needed in order to study true quantum gravity effects beyond general relativity. Tannen says a quantum theory of gravity is needed in order to understand what kind of phenomena there are in cases where there's a gravitational field with high energies, the sort of conditions you'd find around black holes and very early in the universe's existence, just after the Big Bang. And they're the sort of places where existing theories of physics all stop working. Now, although the hypothesis is promising, the authors point out they've not yet completed its proof. It uses a technical procedure known as renormalization. That's a mathematical way of dealing with the infinities that show up in the calculations. Now, so far, the authors have shown that while this works up to a certain point for so-called first-order terms, they're yet to make sure that these infinities can be eliminated throughout the entire calculation. You see, if renormalization doesn't work for higher-order terms, you'll get infinite results. So it's vital to show that this renormalization continues to work, and therefore they still need to make a complete proof. Nevertheless, it's fascinating work. This is SpaceTime. Still to come, is there a hot side to the moon? And astronomers discover their first white dwarf pulsars. All that and more still to come on SpaceTime. Today's episode of SpaceTime is brought to you by Insta360, the game changer in 360-degree camera technology. Now, if you've ever wondered how some creators manage to capture those jaw-dropping third-person shots, the ones that look like they've been taken by a drone following you, well, that's probably Insta360 magic. Their latest model, the X5, isn't just another action cam. It's a fully blown immersive video powerhouse, putting a production studio in the palm of your hand. The X5 captures 8K 360-degree video, meaning you're recording literally everything around you at once, forward, backwards, and sideways. And here's the kicker, you don't even have to aim. Just press record and enjoy the moment, and then reframe your shot after the fact with the Insta360 app's AI-powered tools. Want to follow your movement, lock onto a subject, or create stunning 360-degree pans? Well, now that's just a few taps away. And for those epic how on earth do you film that shots, the invisible selfie stick's your secret weapon. It vanishes from the footage, giving you that cinematic floating camera look, perfect for POVs, adventure reels, or even space-themed explorations right here on Earth. Plus, with a larger sensor and a dedicated night mode, your low-life footage doesn't just survive, it thrives. Think clear skies, dazzling cityscapes, or even a starlit time-lapse. This is hands down the best 360-degree image quality Insta360 has delivered yet. So, if you're a creator, explorer, or just someone who loves telling stories in a bold new creative way, the X5 is ready for launch. To bag a free 114cm invisible selfie stick worth $24.99 US with your Insta360 X5 standard package purchase, head to storeinsta360.com and use the promo code SpaceTime. But be quick, it's available for the first 30 standard package purchases only. And for more information, be sure to check out the links in our show notes. Head to storeinsta360.com and use the promo code SpaceTime. And now, it's back to our show. A new study claims the moon's near or Earth-facing side is actually hotter than its far side. The findings, reported in the journal Nature, are based on data from NASA's Grail spacecraft and the twin Ebb and Flow spacecraft, which have been studying the moon from orbit. Our moon is gravitationally tidally locked to the Earth. That means the same side always faces our planet. Even more fascinating is the dichotomy of the moon, which has long intrigued scientists. You see, there are notable differences in geology, volcanism, and crustal thickness between the lunar near and far sides. The moon's near side appears darker, and it's dominated by smooth ancient lava flows, indicating a high concentration of volcanism. On the other hand, the far side is far more rugged. The new study, using data from Grail, suggests that this dichotomy is caused by a 2 to 3% difference in the lunar mantle's ability to deform on each side. The authors suggest that the reason is that the moon's near-side mantle is up to 170 degrees Celsius hotter than its far side. It's thought this thermal difference could be caused by the radioactive decay of thorium and titanium within the moon's near side, which could be a remnant of the volcanic activity that formed the near-side surface between 3 and 4 billion years ago. The authors say the same methods which have now been used to study the moon's interior from orbit could also be used to measure differences in the structure of other planetary bodies, such as the red planet Mars, the Saturnian moon Enceladus, and the Jovian moon Ganymede. This is SpaceTime. Still to come, astronomers discover a white dwarf star acting like a pulsar, and the June solstice, the constellation Sagittarius, and the Taurids meteor shower are among the highlights of the June night skies on Skywatch. A white dwarf and a red dwarf have been discovered closely orbiting each other and emitting radio pulses every 2 hours. The Findings reported in the journal Nature Astronomy mean that neutron stars are no longer the only stellar bodies that emit such pulses. Now, a key factor in this discovery could be the way the binary pair is spaced unusually far apart from each other. Thanks to follow-up observations using optical and X-ray telescopes, the study's authors were able to determine the origin of these pulsars coming from this binary system with certainty. The findings are important because they're helping to explain the sources of these strange radio emissions, which are found right across the Milky Way galaxy. This is SpaceTime. And time now to check out the night skies of June on Skywatch. June is the fourth month of the old Roman calendar, and it's named after Juno, who was the wife of Jupiter, and is also the equivalent to the Greek goddess Hera. Another belief is that the month's name actually comes from the Latin word juniors, which means younger ones. It's a great time to look up at the night skies and marvel at the majesty of the Milky Way as it puts on its spectacular overhead display. June also marks the winter solstice in the southern hemisphere, which this year happens at 12:42 in the afternoon of Saturday, June the 21st, Australian Eastern Standard Time. That's 10:42 in the evening of Friday, June the 20th, US Eastern Daylight Time, and 2:42 in the morning of Saturday, June the 21st, Greenwich Mean Time. And while it means the start of winter south of the equator, it means the arrival of summer for our lucky listeners in the northern part of the planet. The June solstice occurs when the sun reaches its most northerly point in the sky as seen from Earth, zenith appearing to be directly above the Tropic of Cancer. See, Earth's seasons are governed by the tilt of the planet's axis as it journeys around the sun. Now, the Earth's axis is always pointed the same direction in space, regardless of the position of the planet Earth as it orbits around the sun. So, on the day of the June solstice, Earth's south pole is tilted by 23.5 degrees away from the sun, while the North Pole is tilted by the same amount towards the sun rising in the northeast and setting in the northwest. Of course, 6 months later, when the South Pole is tilted towards the sun, it's the southern hemisphere's summer. And in between, we have the autumn and spring equinoxes. Temperatures on Earth aren't determined by Earth's orbital distance from the sun, but rather the angle of the sun's rays striking the Earth. So in summer, the sun's high in the sky, and the rays hit the planet at a steep angle. In winter, the sun's lower in the sky, and the rays strike the Earth at a far shallower angle. Now, in most parts of the world, the seasons begin on the day of the solstice or equinox. However, Australia is weird. Here, seasons begin on the first day of a specific calendar month. That means the 1st of March for autumn, the 1st of June for winter, the 1st of September for spring, and you guessed it, the 1st of December for summer. Okay, let's check out the stars. Well, almost overhead this time of the year, we find the constellation Virgo. Virgo is named after the goddess of justice and the harvest in ancient Greek mythology, who used her scales to weigh good and evil. However, she became so disenchanted with the evil deeds of men, she wound up throwing away her scales and retreated to the heavens. Now, interestingly, the ancient Egyptians also associate Virgo with agriculture. There, she was the goddess Isis, who sprinkled the heads of wheat across the sky, forming the Milky Way. To science, Virgo is a tightly packed region containing some 2,000 galaxies, all gravitationally bound into a giant galaxy cluster some 60 million light-years away. In fact, our own local group of galaxies, dominated by the Milky Way and Andromeda, are outlying members of this group. The Virgo cluster is at the heart of what's known as the Virgo supercluster, a massive galactic node in the large-scale cosmic web-like structure of the universe. The mass of the Virgo supercluster is so great that its gravity generates the Virgo-centric flow, causing our Milky Way galaxy as well as Andromeda and all the other members of the local galactic group to move towards the supercluster at around 400 kilometers per second. And that's despite the accelerating expansion of the universe over cosmic timescales. The Virgo supercluster is now thought to be a lobe on an even larger galactic supercluster called Laniakea, the centre of which is known as the Great Attractor. Despite the Virgo cluster's size, it's so far away from us it's hard to see without a decently sized backyard telescope. You'll need something at least 100 millimeters in diameter or larger in order to see it. Now, if you look directly straight up at zenith, you'll see the constellation Corvus the Crow. Greek mythology tells us that Corvus could talk to humans, but he was a lazy bird, and so Apollo took away his ability to speak and banished him to the heavens. One of the most spectacular highlights of the constellations Virgo and Corvus is the spectacular Sombrero Galaxy M104. Visible with a good pair of binoculars or a small backyard telescope, this stunning spiral galaxy is seen almost edge-on, and it will provide you with a spectacular backlit view of its galactic bold stars and the molecular gas and dust lanes in its arms. M104 is located some 31 million light-years away, and it's moving away from the Milky Way at about 1,000 kilometres per second. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. The Sombrero Galaxy has a diameter of around 50,000 light-years, making it about 30% the size of our Milky Way galaxy. It's surrounded by up to 2,000 globular clusters, and it has an active central supermassive black hole at least 1 billion times the mass of our Sun. Now, by comparison, Sagittarius A star, that's the supermassive black hole at the centre of our own galaxy, has just 4.3 million times the Sun's mass. Globular clusters are either the central remnants of smaller galaxies cannibalised by larger ones, or alternatively, they're tight balls comprising millions of stars, which were all originally formed at the same time in the same collapsing molecular gas and dust cloud. By the way, the brightest star in Virgo is Spica, a spectroscopic binary located some 250 light-years away. Spectroscopic binaries are stars that are orbiting so close together they can only be told apart by their individual spectrographic signatures. Now, looking about 20 degrees above the western horizon early in the evening this time of the year, you'll find the fourth brightest object in the sky, the dog star Sirius. Only the Sun, the Moon and the planet Venus look brighter. Looking to the northwest or right of Sirius, you'll find another fairly bright star, Procyon, the brightest star in Canis Minor, the lesser dog. In Greek mythology, Canis Major and Canis Minor were Orion's hunting dogs. Procyon is a binary star system. It comprises a spectral type F main sequence white-yellow star, Procyon A, and a faint white dwarf companion, Procyon B. Main sequence stars are those undergoing hydrogen fusion into helium in their cores. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in. Then there's spectral type K orange stars, and the coolest and least massive known stars are spectral type M red stars. Now, each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you can add a Roman numeral to represent luminosity. Put all that together, and our Sun is officially classified as a G2V or G25 yellow dwarf star. Now, also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which can be up to 13 times the mass of, say, Jupiter, and the smallest spectral type M red dwarf stars, which are around 75 to 80 times the mass of Jupiter, or around 0.08 solar masses. Now, the other type of star we just mentioned were white dwarfs. They're the stellar corpses of Sun-like stars. Having used up all its nuclear fuel supply fusing hydrogen into helium, these stars expand into red giants as they fuse helium into carbon and oxygen. The Sun and stars like it aren't massive enough to fuse carbon and oxygen into heavier elements, so they turn off. Eventually, their outer gaseous envelopes will float off into space as spectacular objects known as planetary nebulae. What's left behind is a super-dense white-hot stellar core about the size of the Earth. This is the white dwarf, which will slowly cool over the eons. The white dwarf, Procyon b, is about 0.6 times the mass of the Sun and has a diameter of around 8,600 kilometres. Located about 11.6 light-years away, Procyon a is about 1.5 times the mass and twice the radius of our Sun. But it also has some 7 times the Sun's luminosity. That makes it unusually bright for a star of this type, and that suggests that it's now starting to evolve off the main sequence, having fused nearly all of its core hydrogen into helium. So that means it's slowly expanding out to become a subgiant, as it begins fusing its core helium into oxygen and carbon and burning hydrogen further out from the core. As it continues to expand, the star will eventually swirl to somewhere between 80 and 150 times its current diameter, in the process becoming a red or orange giant. This will probably happen within the next 10 to 100 million years. The two stars, Procyon A and B, orbit each other every 40.82 Earth years at an average distance of 15 astronomical units, about the distance Uranus is from the Sun. An astronomical unit is the average distance between the Earth and the Sun, which is around 150 million kilometres or 8.3 light minutes. Now, looking towards the north-northwest right now, and you'll see the constellation Leo the Lion, looking like a bunch of stars shaped like an upside-down question mark. Located just 36.7 light-years away, Arcturus is a bloated, aging red giant, about 7.1 billion years old and nearing the end of its life. Having used up all its core hydrogen, it's now fusing helium into carbon and oxygen. This has caused the star, which is only slightly more massive than our Sun, to expand out to around 25 times the Sun's diameter, in the process becoming about 170 times as luminous. It will soon puff off its outer gaseous envelope as a planetary nebula, revealing its white-hot stellar core. Now, in Greek mythology, Arcturus was the guardian of the bear. Now, this is a reference to it being next to the constellations Ursa Major and Ursa Minor, the greater and lesser bears. Now, there's some indications that Arcturus could have a binary stellar companion, but the results remain inconclusive. There's also some speculation that it could have a large planet or substellar object, around 12 Jupiter masses, orbiting it. That's close to brown dwarf size, but again, the search remains inconclusive. Now, to the east are the three brightest stars in the constellation Libra, the Scales of Justice. They're visible about halfway, about 40 degrees above the horizon. These represent the claws of Scorpius the Scorpion, which is chasing Orion across the sky. The brightest star in the constellation Scorpius is Alpha Scorpii, or Antares, the Scorpion's heart. Easily seen with the unaided eye, this red supergiant is some 550 light-years away, and it's one of the largest known stars in the universe. It has about 18 times the mass and 883 times the diameter of our Sun, and it has some 10,000 times more luminosity than our Sun. Now, looking to the southeast now, and you'll see the constellation Sagittarius, the Archer. Sagittarius marks the direction of the centre of our galaxy, the Milky Way. It's located 26,000 light-years away and is home to the galaxy's supermassive black hole, Sagittarius A star. To the ancient Babylonians, Sagittarius was the god Nergal, the centaur, a creature that was half man and half horse. By the time Greek mythology took over, Sagittarius was carrying his bow, loaded with an arrow pointing towards Antares, the heart of Scorpius the Scorpion. The centre of the Milky Way galaxy and its supermassive black hole Sagittarius A star lie in the westernmost part of the constellation Sagittarius. One of the brightest stars in Sagittarius is Alpha Sagittarii, or Rukbat, meaning the Archer's Knee, a spectral type B blue star. Located 182 light-years away, it is some 2.5 times the diameter of the Sun, and it's about 40 times as luminous. Astronomers think it's surrounded by a dense debris disk and a newborn companion star, which is only just joining the main sequence. Now, the overall brightest star in Sagittarius, or Caus Australis, the southern part of the bow. Epsilon Sagittarii is a binary star system, located 143 light-years away. The primary star is an evolved spectral type B blue giant, now at the end of its life on the main sequence. It has about 3.5 times the Sun's mass, almost 7 times its radius, and it's radiating around 363 times the Sun's luminosity. It's also a very strong X-ray source, and it's spinning incredibly rapidly with an estimated radial velocity of some 236 kilometers per second. The system also displays an excess of infrared radiation emissions, suggesting the presence of a circumstellar disk of dust. The second star in the system appears to be inside this debris disk. Now, astronomers are speculating that this may well develop into a spectral type G yellow dwarf star with about 95% of our Sun's mass. Sigma Sagittarii, or Nunki, is the constellation's second brightest star. We know the name Nunki has Babylonian origins, however its meaning remains a mystery. It's thought to represent the ancient Babylonian city of Urdu on the Euphrates River. Now, if correct, that would make Nunki the oldest known star name currently in use. It's a spectral type B blue star, located about 260 light-years away. It has about 8 times the Sun's mass, about 4.5 times its radius, and some 3,300 times the luminosity of our Sun. Zeta Sagittarii, or Acela, the armpit, is a binary star system 88 light-years away from the Sun. It's currently speeding away from the solar system, but may once have been as near as 1.5 light-years from the Sun about 1.4 million years ago, and that would make it a former close neighbour. One of the stars in the system is a spectrotype A white giant, while the other is a spectrotype A white supergiant, the pair orbiting each other every 21 Earth years. The system's combined mass is thought to be 5.26 times the mass of our Sun. Delta Sagittarii appears to be a double-star system located around 348 light-years away and listed as an orange giant. Then there's Eta Sagittarii, another double-star system, this one located 146 light-years from Earth. The primary star in the system is an aging, bloated red giant on the asymptotic giant branch. That means it's no longer fusing hydrogen or helium at its core and is instead fusing heavier elements, burning hydrogen and helium in the shell. It's already expanded out to some 57 times the radius of our Sun and is now nearing the end of its life. The second star in the system is the spectrotype F main sequence white-yellow dwarf, which appears to be in a binary system with the primary star, orbiting it every 1,270 Earth years. Pi Sagittarii, or Abalda, is a triple star system located 510 light-years away. The primary star in the system appears to be a spectrotype F white-yellow giant, which has exhausted its core hydrogen and so is now off the main sequence and evolving into a red giant. We know Pi Sagittarii has 2 nearby companions, but little's known about either of them. Beta Sagittarii, or RCAP, the Achilles tendon, is the designation shared by 2 separate star systems. One's about 378 light-years from Earth, the other 139 light-years away. Beta Sagittarii A is a spectrotype B blue dwarf star, while Beta Sagittarii B is a white-yellow giant. Lying nearly at the very centre of the constellation Sagittarius is Nova Sagittarii, which was only discovered in 2015 and, as its name suggests, is a nova, a white dwarf in a binary system with another star which is constantly drawing material off its companion. Now, once enough material reaches the surface of the white dwarf, this added mass triggers a thermonuclear explosion, causing the star to suddenly light up like a beacon and then slowly begin fading again over the following weeks and months. Now, this blast isn't strong enough to destroy the white dwarf, only the additional material that it's picked up. And with this additional material now burnt off, the same cycle can start over again, and the process can repeat itself on timescales ranging from every few years to tens of thousands of years apart. The Sagittarius constellation also hosts many star clusters and nebulae, including some of the best-known astronomical objects in the sky. These include the Lagoon Nebula Messier 8, a spectacular pink emission nebula located 8,000 light-years away, which measures 140 light-years by 60 light-years across. The central area of the Lagoon Nebula is also known as the Hourglass Nebula because of its distinctive shape. The shape's caused by matter propelled by a massive star forming in a region known as Herschel 36, one of the few star-forming nebulae that's possible to see with the unaided eye. The Lagoon Nebula was instrumental in the discovery of what are known as Bok globules, more than 17,000 of which have now been found in the nebula. Astronomers believe Bok globules contain embryonic protostars destined to eventually become new stellar generations. Probably the best-known nebula in Sagittarius is Messier 17, the Horsehead Nebula. It's located 4,890 light-years away and is a dense region of ionized atomic hydrogen. Also known as the Omega or Swan Nebula, it spans some 15 light-years in diameter and has some 800 times the mass of our Sun. It's considered one of the brightest and most massive star-forming regions in our galaxy, with a geometry very similar to the Orion Nebula, except that it's viewed edge-on rather than face-on. The open star cluster NGC 6618 is embedded within the nebulosity, and it causes the gases of the nebula to shine due to intense radiation from these hot young stars. Open star clusters are loosely bound groups of a few thousand stars which were originally all formed in the same molecular gas and dust cloud, but are not as tightly bonded together as the stars in globular clusters. It's thought open clusters generally survive for a few 100 million years, with the most massive ones surviving for maybe a few billion years. Now, in contrast, the more massive globular clusters exert far stronger gravitational attraction to their members, and they therefore can survive much longer in cosmic time. The nebula is thought to contain over 800 stars, including more than 100 of the largest, most massive spectrotype O and B blue stars. More than 1,000 additional stars are now being formed in the surrounding molecular gas and dust clouds. It's also one of the youngest known clusters in the galaxy, with an age of just 1 million years. The cloud of interstellar material forming the nebula is roughly 40 light-years in diameter, and it's thought to contain some 30,000 solar masses. Another famous nebulosity is the Trifid Nebula Messier 20. It's another large star-forming emission nebula containing many very young hot stars. Located somewhere between 2,000 and 9,000 light-years from Earth, the Trifid Nebula has a diameter of around 50 light-years. Now, the outside of the Trifid Nebula is a bluish reflection nebula, while the inner region is glowing pink thanks to ionized hydrogen. There are 2 dark bands dividing the Trifid Nebula into 3 regions or lobes. Hydrogen in the nebula is being ionized by a central triple star system, which formed in the intersection of the 2 bands, creating the characteristic pink colour. Other star-forming regions, such as NGC 559, which is located 5,000 light-years from Earth, contain both red emission and blue reflection regions. This grouping of the Lagoon Nebula, the Trifid Nebula, and NGC 6559 is known as the Sagittarius Triplet. Another spectacular sight in Sagittarius is the Red Spider Nebula NGC 6537. It's a planetary nebula some 8,000 light-years from Earth. It has a prominent 2-lobe shape. Now, this could be due to a binary companion or possibly magnetic fields, and has an S-shaped symmetry with the lobes opposite each other appearing similar. The central white dwarf, remnant to the original star, produces a powerful 10,000-degree hot 3,000 km per second stellar wind. And that wind's generating 100 billion kilometre high waves of supersonic shocks, which are formed as local gas is being compressed and heated in front of the rapidly expanding lobes. Atoms caught in the shock front are radiating invisible light, giving the nebula its unique spider-like shape and also contributing to its expansion. The star at the centre of the Red Spider Nebula is shrouded by a dust shell, making its exact properties hard to determine. We think it has a surface temperature of around 25,000 degrees, although temperatures of up to 500,000 degrees can't be ruled out, which would make it one of the hottest white dwarf stars known. Now, if you look directly south this time of year, you'll find the star Polaris Australis, or more accurately Sigma Octantis, the nearest star to the southern celestial pole, and consequently the counterpart to the North Star Polaris. However, Sigma Octantis is much harder to see than Polaris because it's much fainter. Located some 270 light-years away, it's now an orange giant nearing the end of its life. Turning to the southwest, just above the horizon, and we find Canopus, the second brightest star in the night sky after Sirius. It's located some 310 light-years away and is the brightest star in the constellation Carina the Keel. Canopus is a supergiant, some 9 times the mass of the Sun and some 71 times its diameter. The month of June also marks the first of 2 annual encounters with the Taurids meteor shower. The Taurids are generated as the Earth passes through a debris stream left by the comet 2P Encke, which itself could be pieces of a much larger comet that broke apart around 20,000 to 30,000 years ago, most likely following numerous interactions with the powerful gravitational field of the planet Jupiter. As their name suggests, the Taurids' radiant, or apparent point of origin, is in the constellation Taurus the Bull. The Taurids' meteor shower is made up of larger, more massive material, think of pebbles instead of dust grains. Earth passes through this stream twice every year, once in June, then again in October, when they're referred to as Halloween fireballs. The Taurids release material, both by normal cometary activity and occasionally through close encounters with the gravitational tidal forces exerted by the Earth and other planets. And all this makes the Taurid stream of material the largest in the inner solar system. Now, since this meteor stream is rather spread out in space, planet Earth takes several weeks to pass through it, causing an extended period of meteor activity compared with the much smaller periods of activity by other meteor showers. Now, included in the Taurid stream is a denser flow of gravelly meteors called the Taurid swarm, and they're thought to be a ribbon of rocks roughly 75 million kilometres by 150 kilometres across and held in orbit by Jupiter's gravity. Now, occasionally, planet Earth passes through the larger meteors in this denser Taurid swarm. And one of the larger chunks in the Taurid swarm is now thought to have caused the infamous Tunguska event in the skies above Siberia on June 30th, 1908. The Tunguska event is now believed to have been the airburst of a 100-metre-wide meteor in the skies above the Tunguska region of Russia, resulting in mass devastation over a 2,000 square kilometre region of forest, turning trees into matchsticks. In fact, the blast was so bright it lit up the night sky in London a third of the way around the planet. The Tunguska event remains the largest known Earth impact event of a meteor in recorded modern times. Now, it's always been considered to be a 1-in-1,000-year event, assuming a random distribution of events over time. But there's a problem with that because of these new studies suggesting the event may have been caused by a Taurids swarm meteor, and with the Earth passing through the Taurids swarm periodically, it changes the odds considerably. Now, if this new study is correct, the swarm heightens the possibility of a cluster of large impacts on Earth over a short period of time. Now, further complicating matters, the June Taurids are actually two separate showers. The southern Taurids are associated with the comet 2P Encke, while the northern Taurids originate from the asteroid 2004 TG10, an eccentric kilometre-wide asteroid classified as a near-Earth object and a potentially hazardous asteroid of the Apollo group. Something to think about. Joining us now for the rest of our tour of the night skies of June is science editor Jonathan Nally.
G'day, Stuart. Yeah, well, it's June, so June evenings start off with the constellation Orion, low in the west. So Orion's one of our favourite constellations, isn't it? I love Orion. Everyone loves Orion. It's very easily recognisable, but it is low in the west after sunset. And as the Earth turns during the evening, it dips below the horizon pretty quickly. And by the middle of the month, it's actually going to be gone. After sunset, you won't be able to see it anymore. But it will reappear towards the end of the year in the eastern sky. And that's when Orion appears in the eastern sky at the end of the year, that's when you know that for people in the southern hemisphere, summer is arriving. Or for people in the northern hemisphere, they know that winter is arriving. So it's a good signpost, the old Orion. But yeah, you get your last glimpse of it now, basically, in the evening, in the first half of June. Also, in the western part of the sky, there are two bright stars. One's called Sirius, the other one's called Procyon. Sirius is the brightest star in the night sky. Procyon is the eighth brightest, still very bright. And they have a few similarities, actually. They're both binary stars, and each of them is what they call a main sequence, a normal sort of star with a white dwarf going around it, a white dwarf star. And they're both within constellations that have the word dog in the name. Sirius is in the constellation Canis Major, or the greater dog, and Procyon is in the constellation Canis Minor, or the lesser dog. In the southwest, there's another bright star, Canopus. Canopus is my favourite star in the whole sky, I reckon. It's the second brightest star in the night sky, about half as bright as Sirius. You only get a really good look at it if you're in the southern hemisphere. From people in the northern hemisphere, sort of lower latitude, you can see it certain times of the year, but from down here, it's pretty much visible all the time.
It's actually the most luminous star in our neighbourhood. It's huge.
Yeah, it is. It's about 10,000 times brighter than our sun, about 10 times its size, and fortunately, it is about 310 light years away, which is very close in space terms, but if it was much closer than 310 light years away, it would be very, very bright indeed. I mean, if it was, a fraction of that distance, we really wouldn't have a night sky.
Is it the case that Canopus was once closer to our star system than Sirius and then it moved away and it's slowly coming back again?
I think it is the case, yeah. I think it is the case that the distances have changed a little bit, and Canopus at one point was brighter than Sirius, I think. So, we're moving, our solar system is moving through space, and Sirius is moving through space, and Canopus is moving through space. So the distances between each other are moving around a bit. But Canopus at the moment is not as bright as Sirius. Sirius is the brightest star, but you go out to the naked eye, telling one star apart of that brightness, telling one star apart from another is it's not the easiest thing to do. If you get a good look at both and you say, well, Sirius is brighter, but they both are very, very bright. But yeah, I don't know. Canopus is just one of my favourites, really. I guess because it was one of the first stars I identified when I was a kid, and it's because it's a nice bright star far down in the southern star. We sort of got it all to ourselves, sort of thing. So it's just got a sort of a sentimental value for me.
We're very lucky in the southern hemisphere, aren't we?
Oh, we're super lucky in the southern hemisphere. We've got lots of bright things. We've got the centre of the Milky Way galaxy overhead, and we've got the Magellanic Cloud galaxies. There are plenty of good things, which is not to say that there aren't plenty of great things in the northern sky as well, but we do have a few extras, it seems, down here that makes it a bit special. Now, high in the south, about 2/3 of the way up from the horizon down in the south, you've got the Southern Cross this time of year, and it's standing upright for a change, because a lot of the year it's either upside down or on its left side or on its right side or whatever, but round about now it's pretty much standing upright. Nearby, you've got the pair of stars known as the two pointers, Alpha and Beta Centauri. We talk about those a lot on the show. The Milky Way runs right through this region of the cross. It's sort of heading from east to west across the sky. And there are plenty of star clusters and nebulae for amateur astronomers to enjoy looking along its length. Even with a pair of binoculars, with a telescope, it's great, particularly if you've got one that gives you a wide field of view. But just binoculars, it's really superb along there. You do need dark skies, though. City skies do make it very, very hard with all the light pollution. Now, if you do have really dark skies and you've got a clear southern horizon, you might be able to see two smudges of light above the southern horizon, and those are these Magellanic Clouds I was talking about earlier. These are small, odd-shaped galaxies that are very close to the Milky Way. They're the nearest sizable galaxies to our own, and you can see them just with the naked eye. If you've got dark skies and you let your eyes get adapted to the dark, they just look like clouds. They look like tiny clouds, hence their name, Magellanic Clouds. There's actually a bit of a push on to rename them, do away with the name Magellan, because, in keeping with the way things are these days, Mr. Magellan, or at least the voyage that he was on, was not too kind to some of the people and places that they visited on their around-the-world trip. So in the spirit of that, some people are trying to have those clouds renamed, small and large Milky Clouds, or something along that line, sort of similar to the Milky Way. So we'll see how far that gets. In the northern half of the sky, as seen from the southern hemisphere at least, it does seem a bit bare this time of year, but there is the bright star Taurus, which you can see about halfway up from the northern horizon, and you've got another bright star that's reasonably overhead from the latitude of, say, Sydney. That star's called Spica. And as the night goes on, though, you'll see that things have changed because the Earth is rotating. By midnight, Sirius has already set in the west. The brightest star has already set in the west. And a couple of other bright stars have appeared in the north. You've got Vega and Altair, which are very famous stars. They appear in lots of science fiction and TV series, those sort of things. And there's another star in the southeast, actually, another one like very far in the southeast, down the southern sky. It's one of these ones that you see really only from the southern hemisphere. It's called Achernar. And that's actually another one of my favourite stars. Again, probably just because it's sort of special because it's only visible from the south. And the Milky Way, which was stretching, as I said, stretching east to west, sort of horizontally across the sky, it's now stretching from the northeast to the southwest, sort of diagonally across the sky. That's just because the Earth is turning and we get a different perspective. Now, turning to the planets, what have we got? Well, we've got Jupiter at the moment is out of view. It's too close to the sun to be seen. That'll be that way for a little while. The same goes for Mercury, actually. Although if you are lucky, and by lucky I mean if you've got a good clear horizon and there's no buildings and trees and things in the way, you might just be able to spot Mercury very low above the western horizon after the sun has set in the last week or so of June. Other than that, it's very, very close to the sun and very hard to see. Around mid-evening time, after it gets dark, Mars can be seen about halfway up from the horizon very easily. It's a sort of looks like a red star or an orangey reddish kind of star. As I say, about halfway up from the horizon to the north if you're viewing from the southern hemisphere, or to the south if you're viewing from the northern hemisphere. So see if you can spot that one. If you want to spot Saturn, you have to stay up a bit later. It rises above the eastern horizon about 1:30 a.m. at the beginning of the month, and by about midnight at the end of June, which is a bit past my usual bedtime these days. But if you're out and about late, you should be able to spot it quite easily. It's fairly bright, has a slightly yellowish tinge. So it's coming up over the horizon about 1:30 a.m. at the beginning of the month. And finally, we've got Venus, which will also be rising over the horizon. It follows Saturn, but at around about 3:45 a.m. So you have to stay up very, very late for that one. Night owls will be able to get a view of that, but you can't miss Venus at all. So I always say it's so big and bright, you just can't miss it. It's the third brightest thing in the sky after the sun and the moon. So nighttime, of course, very easy to spot Venus.
You'll be just coming home from the club at that time, won't you?
Coming home from the club in my dreams, I think. No, I think night owls, those who on night shifts, and those people getting up early for morning shifts will be able to spot it. It's one of these things actually where there are a lot of UFO reports when people, say get up early in the morning. They're not accustomed to being up early in the morning, and they look out and see this bright white light. It doesn't seem to be moving, and they think, oh, it's a UFO. Where it wasn't there yesterday. The reality is that it was there yesterday. You just didn't notice it, and that's Venus. Sometimes Venus is visible in the morning sky, and sometimes Venus is visible in the evening sky, and the same goes for Mercury. So it does tend to move around a little bit, but there's nothing like a view of Venus. And if you get out, as we say, if you go bush, get away from the cities, get away from the city lights and everything, so you get really dark skies. When Venus is big and bright and up like that, it throws shadows. It's bright enough to throw shadows. You can see where you're going just by the light of Venus alone. It's really quite remarkable. Interesting thing about Venus, found this from a old Isaac Asimov book. Now, I don't know whether he was the first one to come up with this idea or not, but I read it in an old, because he used to write science essays and science columns and science books and things, as well as his science fiction. And he said that, because we've got the moon going around the Earth, right, which is a fairly big moon compared to the size of the Earth. The Earth moon's
It's a quarter of the size of the Earth. It's huge.
Yeah, some people might call it a double planet system in a way, because it's a very large moon.
If the moon was just a little bit closer, the barycenter would be outside the Earth, and under those circumstances, then we would be a binary system, like Pluto and Charon.
That's exactly right. Now, what he proposed in this article was, and this could have changed the course of history actually if this had happened, was that if the moon hadn't formed around Earth, if instead it had formed in orbit around Venus, and Venus is about the same size as the Earth, then at the distance of Venus, when the moon was at its furthest from Venus, you would be able to see, just with the unaided eye, you would be able to see Venus and its moon, its theoretical moon or hypothetical moon, separated on the night sky, and you would see that moon's position changing from night to night, and you would be drawn to the inescapable conclusion that small dot was circling the larger dot, right? So something was going around something else. And of course, we remember from our history about things, were things going around the Earth, or was the Earth going around the sun? So the sun going around the Earth, or Earth going around the sun. And for a long time, of course, it was people had the wrong
Galileo
idea.
And Copernicus before him.
Yeah. Well, see, up until Galileo, looking through his telescope to see that the moons were going around Jupiter, so something else, and yet it moves, and something's going around Jupiter. Well, if the moon had formed in orbit around Venus, then we would have known since antiquity, since prehistoric times, that something was going around something else out there in space, and therefore we would have known that not everything goes around the Earth, in other words. So this whole idea that the Earth being the centre of everything, which sort of held us back for a very long time, might not have taken hold, or at least not as widely taken hold or for as long. So just one of those accidents of nature that the moon formed in orbit around the Earth rather than Venus. Interesting, isn't it?
For a long time, people used to think that because Venus is covered in clouds and it's a bit closer to the sun than the Earth, then those clouds must mean lots of rain. Lots of rain means lots of water on the ground. Lots of water on the ground means lots of trees could have grown, lots of forests, probably tropical rainforest would have grown there.
Yeah, because Venus is closer to the sun, therefore it would have been warmer. So, tropical rainforest and probably dinosaurs roaming around.
And dinosaurs was the next thing that came up. You're right, yes. Some scientists even postulated that, well, if you've got tropical rainforest, you've probably got dinosaurs. How they reached that conclusion, I don't know. But that was very common back in the 50s and 60s. A lot of scientists supported that idea.
It was speculation, and I mean, it was sort of a very uneducated guess, but you can sort of understand it.
It's like the canals on Mars, isn't it?
Yeah, the canals on Mars. See, it's hard for people these days, I suppose, to think about this, but you go back to the turn of the 19th, 20th century, go back to the year 1900 or whatever, it was widely assumed that there would be life on the other planets. Because if there's life on Earth, why wouldn't there be life on other planets? Because we didn't know what those other planets were like back then. We didn't have the technology to really establish what the atmospheres were made of and what the temperatures might be, all that sort of thing, at least with not any great precision. And so even when the first NASA spacecraft were getting to Mars, it was still people were thinking, well, that's going to show things on Mars, might show vegetation or whatever. But then the first picture started coming back, which just showed a desert world with craters and things. So for a long time, people just assumed that there was going to be life on the other worlds. Then we started to learn, that Mars is actually really cold. It's got a thin atmosphere, and Venus has got a runaway greenhouse effect, so it's very, very hot, and the air pressure would be very, very intense. About 90 atmospheres or something, and temperatures of over 400 degrees Celsius, 450-something degrees Celsius, and possible sulfuric acid rain from the clouds. So
metallic snow on the cloud tops, by the way.
We've got a far more sophisticated idea of what things are like out there now. But back in the early days when we didn't really know, people just assumed. So, but goodness knows how many things we take for granted as being true right now. This year in 2025, which 100 years from now or 50 years from now, will be considered complete nonsense. So I'm not critical of people who thought various things in past times when they had some reason to think that might have been. It's when you get people who just totally ignore the evidence or try and work their way around the evidence. So, for instance, Percival Lowell looked at finding these canals on Mars, but no one else could see them. But he just sort of stuck with it because he was sure that there were canals on Mars, and no one else could see them. So that's when you have problems.
Well, the problem was he didn't translate Schiaparelli's original comments correctly. Schiaparelli was talking about canali, but he didn't mean canals; he meant channels. Something
like water channels or riverbeds, that kind of thing. Yeah, they got translated into canals, which in English means an artificial water
they were building a huge canal network in England at the time, weren't they?
Yeah. And he was essentially seeing what he wanted to see. He got it into his mind, and that was the end of it. And that's just a human failing, isn't it? Really. And on that philosophical note, Stuart, we just solved all the world's problems once again. Aren't we good? And I'll see you next month.
That's science editor Jonathan Nally, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.